Alright, part C. Calculate the mass m the counterweight must have to raise the elevator car with an acceleration of 2 meters per second squared. Let's scroll up here and look at the counterweight. Here's our counterweight, and let's draw a quick free body diagram. That counterweight has acting on it weight, or the force of gravity, and tension from the cable. And that tension will be the same as we found in the last problem. So that tension we already know is 5,000 newtons, not 1,400, as I made that little mistake there at the end. Alright, now let's go back and start working on the problem. I'm going to need a lot of space, so I'm going to go ahead and put that at the top of the screen and redraw my free body diagram real fast, weight and tension. Okay, this is asking about acceleration, and we know that there is a force because I just drew a free body diagram. So this is once again an F net problem. Net force equals mass times acceleration. And just like in the last problem, all of these forces are in y. So let's just go ahead and note that we're only dealing with y forces. F net y equals mass times acceleration in y. We know the acceleration in y, it's 2 meters per second squared. We're looking for the mass, so we need F net. Here we go. The forces in y on that elevator car, if I bring this over here, tension, which is positive, minus force of gravity, or weight, equals mass times the acceleration in y. Now note, this elevator is going to, this counterweight has to fall down because the problem says that the elevator car is going up. And since they're on a pulley, they have to go in opposite directions. That means that the acceleration over here is negative. So this term will come out to be negative, because earlier I called positive or up positive y and down negative y. Okay, we know tension from the last problem. Tension. We don't know the force of gravity because we would have to know the mass, and we don't know the mass. So I'm going to go ahead and rewrite force of gravity as we know it to be, tension minus mass times acceleration of gravity equals negative mass acceleration in y. I'm solving for mass, so let's get the masses by themselves. And this is also why I have to, as Ariel asked a couple days ago, why I have to rewrite weight as m times g, because there's actually two things hidden in Fg, m and g. So let's get the masses, and masses by themselves, because that's what we're looking for. Find the mass. So I'll just add mg to both sides. T equals negative mass times acceleration in y plus mg. Okay. I need to find mass, so I have to get it by itself. So let's factor out the mass here. Mass negative ay plus g is equal to t. Now I'll divide by ay plus negative ay plus g on both sides. Ay plus g. So I get t over negative ay plus g equals the mass. Let's plug in those numbers. The tension was 5,000 newtons. Acceleration y is 2 meters per second squared, and we already know it's negative, plus 10 newtons per kilogram. And remember, newtons per kilogram and meters per second squared are the same thing. So that's 5,000 divided by 8. Negative 2 plus 10 is 8. And 5,000 divided by 8 is 625. We're looking for a mass, kilograms. That is the mass of the counterweight that you have to have in order to make the elevator accelerate at 2 meters per second squared. And that is part C. Done. On to the next problem. Calculate the tension in the cable lifting the forward 400 kilogram elevator car during an upward acceleration of 2 meters per second squared. Okay, so I have an acceleration. Therefore, this is not an equilibrium problem. It's not up equals down, left equals right. There is an acceleration. And there's a force mentioned, tension. So this is obviously then an F net problem. F net equals mass times acceleration. And if I look at the forces in my diagram, all of these forces are in y. And so we'll just deal with the y net force since there are no x forces. F net y equals mass times acceleration in y. Okay, we know the acceleration and we know the mass. We're looking for one of the forces, so let's get to work. First, all of the forces in y. I'm going to have up be positive y and down be negative y, as is convention. So first, tension is pointed up, so it will be positive T. Oops, don't know why that moved. Stop that. Ah. Okay, finally got it to work. Tension minus force of friction left is pointed down, so F left, minus Fg minus F right equals mass times acceleration in y. Okay, now we keep going. Let's plug in, actually let's not plug in. We're looking for tension. So tension is what we're looking for. Let's go ahead and solve for tension. So if I move all the others to the other side of the equation, I can get tension by itself. Tension equals F left plus Fg plus F right plus mass times acceleration in y. Okay, now let's fill in what we know. I'm going to take this and move it over here for space reasons. Tension equals, the problem tells me that each friction force is 100 newtons. So 100 newtons plus a 400 kilogram mass would be Fg equals 400 kilograms times times 10 newtons per kilogram. So a 400 kilogram car would be a 4,000 Newton force plus F right, which is 100 newtons, plus mass times acceleration in y, 400 kilograms times 2 meters per second squared. That 400 kilograms times 2, by the way, would be 800 newtons. So now I can just add all those together. 100 plus 400 plus 100, that's 600 so far, plus 800 is 1400. T is 1400 newtons, and that's part B. Alright, right after saying I was done, I realized a little mistake I'd made. This was 4,000 newtons, not 400. So let's do that again. 100 newtons plus 4,000 newtons is 4,100 newtons, plus 100 newtons is 4,200 newtons, plus 800 newtons is 5,000 newtons. I read this 4,000 as 400, so that's 5,000 newtons. Sorry about that mistake. Hopefully it didn't trip anybody up too bad. My mistake didn't come along until I started adding the tensions together.